Oh my God, we are back. It's time to tantalize your senses and expand your mind with the Dart Coding Challenge. This is number 4, and it is called the longest word. So as you may imagine, the goal of this application is to input a body of text and decipher what the longest word in the body of text is. Now, since this is challenge number 4, we're not going to waste any more time talking about what a coding challenge is. If you don't know, view the previous ones. Let's get right into the specifications. Obtain a body of text from the command line. Don't allow the user to leave this blank. The text may only include alphanumeric characters, spaces, and punctuation. The text must include at least 3 words and 1 sentence to be valid. If any of the aforementioned criteria was not met, alert the user as to the problem and prompt them to input again. Once you have the longest word in the body of text, you need to decipher which word is the longest and how many characters that word has in it. If there are 2 words that are identical, return the one that comes latest in the body of text. That's it. You can tackle this problem in any way you see fit. You can use regular expressions, you can avoid regular expressions, you can use all the built-in functionality that Dart has to offer, or you can completely ignore it and do it with the bare minimum. It's up to you. The important thing, as usual, is taking the problem, breaking it down step by step, and figuring out how to think and how to code. It's time to push pause. Do your very best to tackle this problem on your own. If you just get completely stuck and frustrated to the point you want to quit, join us in a few moments where we will start giving you some hints. Hint number 1, use the Dart IO library and standardin.readLineSync to capture input from the command line. Alternatively, if you want to write to the command line without a line break at the end of the sentence, use standardout.write instead of the print statement. The do-while loop can be an excellent control flow structure for when you're trying to prompt users for input repeatedly until certain conditions are met. You may also use the while loop. Using a combination of regular expressions and the list features inside of Dart is going to give you a quick and easy way to solve this problem, however, not the only way. Try experimenting with the split and all matches method. Remember, you can access any character you want in a string by using string name and then inside of brackets a number. The number 0 would be the first character, etc. A for loop is a great way to iterate through every character in a string. You can use much of the code from last week's challenge in order to solve the problem with figuring out how many words and how many sentences are in each body of text. Now it's time to look at my solution 1 for this problem. As you might remember, I've been using the Dart create command to create the projects, which means it's creating a bin folder with a file inside, a lib folder with a file inside, and a test folder with a file inside. So let's take a look at the code that's inside of our bin file for solution 1. You'll notice we have a very simple void main function here. We're passing a list string of arguments, which we're not actually using, but it's good to get in the habit of doing that from this point forward. Now we're creating a map where the key is a string and the value is dynamic, meaning it can be an integer or a string or any type of content we want, called data. And then we're running a function we've created called getFromCommandLine. Then we're creating a string called longestWord to use a function we've created called calculateLongestWord, which is going to use the list of words from the data variable we just got back. And then we're converting it to a string. And then we're simply printing out the longest word and how many characters it has. Remember, we're using the getter length here to access this information. Now let's go look at the lib file, which is where most of the action is happening. The first thing we need to look at is get text from command line. This is going to look very familiar if you've done any of the previous projects. We're initializing a string called input text, which we're leaving blank for the time being. And then this time around, we've also created a string called CLI message, which stands for command line interface message. And we're putting a default value in here. And we're also creating a variable called numData, which is a map of type string dynamic. And we're setting the word count to 0 and the sentence count to 0. We're exploring this a little differently than last time, just so you can see different methods of achieving the same goal. After that, we create a do-while loop. We're executing this loop while the input is empty, while numData word count is less than 3, and while numData sentence count is less than 1. Now, you might be wondering, why did we create a variable called numData instead of just using the count sentences and words function down here? Well, I thought if we created the variable, we only had to run this function once instead of multiple times. And while these are not true, we're executing standardout.write, we're printing out the CLI message variable previously mentioned, and then we're capturing input text with our favorite command, standardin.readLineSync. You do notice we have an exclamation point here to add null safety. Then of course we're creating num data and calling this function. You'll notice based on what our data return is, whether input text is empty or whether num data word count or sentence count is outside of our scope, we are setting the CLI message variable to a different message so that on the next iteration of our do while loop, we will be printing out this message instead of the default that we previously set. And once this is done, we're returning a map with a key called input text, which not surprisingly returns the variable input text. And then we have a second key called word list, which as you might imagine is including a list of words that was created when we ran our count sentences and words function. So this whole section should look very similar to the previous lessons. Most of the new functionality is happening inside of this function, so let's take a look at it. Count sentences and words is of type map string dynamic. So the key is a string, the value is dynamic. And we're passing in a string called input text, obviously. So you'll notice we're using two regular expressions. If you would like to decode these, this is actually a really good use case for a tool like ChatGPT. You can paste these into a tool like ChatGPT, Bing Chat, or Bard, and they'll actually explain to you exactly what this regular expression means. Alternatively, you can look up regular expressions and decode this yourself. Either way, we're not going to focus on that for today's video. And then check this out. We're getting a list of words without the punctuation marks. We're creating a list of strings called words, and we're running on our word regular expression a function called allMatches. Now into allMatches as an argument, we're passing our input text, which is the body of text that the user entered, and then we're converting it to a map. And then if we have a match, we're returning the entire match. When you put 0 inside of this group method, you'll notice it says if group is 0, it returns the entire match pattern. And then once we have those matches, we're turning it into a list. And then you'll see we're returning a map. And since we had type dynamic for the value, we can pass word count as a number, an integer of words.length. We can use sentence count key as a value input text split.length. So we're splitting the input text by the sentence regular expression. We're also returning a list of strings as our words index. So now we've executed our get text from command line, which not only returns the text, but it also returns some data about our application that the rest of the application can use. So then we're calculating the longest word using the list of words that we passed into it. Let's go take a look at how this is done. So now we have a string which is called calculate longest word, and into it we're passing a list of strings called words. So we're setting our current longest word to blank right now because we haven't established it. Then we're going to iterate through the entire list of words. Now we could create our own for loop, but Dart has some nice functionality built into lists called for each. So we're running a for each loop on word, which means it's going to loop once for every word in this list. And then we're just simply checking to see if the word is longer than the previous record, update it. So if word.length is greater than or equal to current word.length, we're setting current longest word to the word. Now, why are we doing greater than or equal to? Remember, if we said two words are equal, we want the second word or third word or whatever it is to be returned as opposed to the first. So that's why we're using greater than or equal to. And then we're returning the current longest word. So since longest word is a string, we can print it here, and then we can print out the number of characters in the longest word by accessing the .length getter. Let's test this application and see how it works. We're going to run Dart run. We're going to enter a sentence. I really hope that this application functions properly. If it does not, I will have to drown my sorrows in Chipotle. Let's hit enter, see what happens. The longest word in the text is application, which contains 11 characters. That's fantastic. So now let's run our tests before we go and show you what we did for the tests here. All tests passed. Great. Let's look at our test file real quick. So the first thing you'll notice is we're grouping two tests together, and we're calling it count sentences and words. The first test says it should correctly count words and sentences. So we have an input text called hello world. This is a test, how are you? And then we're creating a result using our count sentences and words input text. Then we're using multiple expect statements on this data because remember, it's a map that's getting sent back. So we're checking to see if the word count is correct. We're checking to see if the sentence count is correct. And then we're checking to see if the list of words is correct as well. Then we're also making sure that the function handles empty input. So if we enter empty input into count sentences and words, we're getting a word count of 0, a sentence count of 1, and then we're getting a blank list of words. Then we also have a separate group here called calculate longest word. And again, we're running a test to see if the longest word is correct. So we're entering a string of words, and then we're creating a string called longest word. We're running calculate longest word, and then we're checking, or we're expecting longest word in this case to be world, because look, these two are the same, and we want to get the second one per our application specs. Then notice we're running a test to return an empty array string for an empty list. So we're creating a list of strings, words, that's blank. You initialize a list by using brackets. And then we're creating a string called longest word, and once again, we're running our calculate longest word function on our list of words. So we expect there to be no longest word because there are no words. So all of these passed, which means our application is working. So there's some interesting new functionality you should take a little bit of time to understand. One, again, is using the all matches method that can be used on a regular expression, in this case, our word regexp. The second is to make sure you understand how we used the split function on input text and how we passed our regular expression for sentences as our criteria for how to split into this list of words. That's it. We will be back in just a moment with solution number 2. As before, we have a bin, lib, and test folder. Let's open up our bin file first and see what we can see. So you'll notice the bin file is exactly the same as last time. We're using the same main structure in our void main function. So all of the changes we made must be inside of either get text from command line or calculate longest word functions. Let's open them up and see how they look. By the way, if you want to open up a particular function or method in VS Code, on Windows at least, you can hold Control and click on the function name and it will bring it up for you. Is there anything different in here? No, it's exactly the same. So that means none of our changes happened inside of the get text from command line function. Let's go look at count sentences and words for solution 2. This one is a bit different. If you'll remember in a previous video, instead of using regular expressions, we defined lists of characters that were going to end words and end sentences. Then we also created a blank list of words to use. And you'll notice up here, we created a map of string dynamic called results, where we're passing word count, sentence count, and then our list of words. These, of course, are 0 right now, and words is going to be initialized as blank until we put data in there. And then we have some local counters that we can use to set the values. So this is a bit more of a traditional way of solving the problem that doesn't use all the Dart functionality we used in solution 1, and it doesn't use regular expressions. So we're assigning the number of characters variable to text.length, so we know how many times we need to iterate through this loop. Then we're creating a for loop. We're setting I to 0, and we're running this loop over and over while I is less than the number of characters. And then of course we're doing I plus 1 each time we iterate through the loop. So let's look inside the loop. This logic is actually very similar to our count sentences and words application first solution. We have a series of if statements here that execute different actions based on the data. So if end words does not contain text I and end sentences does not contain text of I, we are assuming that this character is part of a word. Now, as a reminder, if you look, word buffer is just a blank string. So we're using this buffer to hold a word as we're iterating through characters. But now you look, if end words contains text I, so if we have something that indicates the end of a word and it doesn't contain text I minus I as end of sentences, we're adding to our list of words, word buffer. And we're setting word buffer back to blank, and then we're adding words plus plus. What we've done here is traverse through our string. And once we find criteria that indicates the end of a word, we're taking all of the characters from the word, we're adding it to the list, then we're resetting that buffer. You'll notice we have similar logic down here that does the same thing. So for instance, this adds a sentence if the current character is on our end of character list. So if end sentences contains text I, which again is just the current character in our string, and it doesn't contain text I minus 1, which is to prevent sentences like I am mad from generating 3 sentences. Once again, we're adding this word to our list of words, the buffer, we're resetting the buffer, and we're adding words plus plus and sentences plus plus. Our last use case here is if the user did not enter punctuation for the last character, we need to classify it as a sentence. So we're just making sure that if I plus 1 equals the number of characters, which means the end of the string, and end sentences doesn't contain text I, we're going to add our word again to the list of words, we're going to reset the buffer, and we're going to add our sentences and words. This might seem like a fairly convoluted way to do it, and I'll admit in the context of Dart and regular expressions it is, but it's good to know how to traverse through strings and use data in different ways, because there are going to be times where you're going to need to do this when either Dart or Flutter doesn't support the functionality you need. Let's scroll back to the top, where we have our map of string dynamic called results. You'll notice we've defined it as a map here. So I wanted to show you a different way to update data inside of a map. So you could, of course, update a map in the following way. You could set your variable results equal to the map. And so in this case, we would say word count is equal to words, sentence count is equal to sentences, and words is equal to list of words. That's great and that's fine, but we're going to comment this out. Another way that you can update maps is to do it individually. So you can use the results variable and you can access the key word count and set it to words. Same for sentence count and words. Why would you want to do this? Well, you don't always want to update every single key in a map, so it wouldn't make sense to write out all this boilerplate that you see up here. Or in some instances, you might just find this easier to read. Normally in this application, I would actually use the first way of doing it, but I did want to make sure you understood multiple ways to update keys and data inside of maps. And there's one more change. If you look at calculate longest word, we're doing this differently. So I left some notes in here. This effectively loops through the entire list and compares A with B, and then uses a ternary operator to return a higher value. So we're making sure that words isn't empty first, because if so, we're going to return blank. So if words isn't empty, we're using a method called reduce. So what reduce does is it reduces a collection or a list down to a single entry. In this case, it actually works perfect. We're comparing A and B, which would basically be the first and second item in our list to start with, and then the second, third, fourth, etc. If A.length is greater than B.length, we are going to use value A. Otherwise, we're going to use value B. I don't know if you know what a ternary operator is, but this is basically how it works. You have an expression, and if the expression is true, you're going to use whatever is after the question mark. If the expression is false, we're going to use whatever is after the colon. Now, before we test our application, let's go look real quick at the tests here. Our tests are actually very similar to solution 1. So we have a group, once again, called count sentences and words, and we're using a test called test with basic input. So we're creating a string called input, we're getting the result of our count sentences and words function, and then we're running expect on some of the information we might expect to get back. So in this case, we would expect 8 words, 2 sentences, and then this list of words. And then we're doing it testing with no ending punctuation to make sure we still get the proper amount of words. So we should get the same word count, we should get the same sentence count, and we should get the same list of words. We're going to test with multiple pieces of punctuation. If you remember when I was talking about our criteria, we said we want to make sure it only counts this as 1 sentence instead of 2. So we're running another test. This is a test, exclamation point, here's another sentence. So we should get 8 words, 2 sentences, and then our list of words. And then we have a new group called calculate longest word, where once again, we're just testing with basic input, we're testing with an empty list, and we're testing with all the words the same length to make sure that we get the third entry as expected. You can take some time and go through these tests if you want in a little greater detail by going to our Substack page that is linked in the description. For now, we're going to do 2 things. We're going to run Dart test and see if all of our unit tests passed, which they do, great. We're going to clear our command line, we're going to run Dart run, we're going to type in Jeffrey Booth is really, 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 really cool, and I think his intellect is rather gargantuan. The longest word in the text is gargantuan, which contains 10 characters. It worked, perfect. I know this one was a little bit trickier, and your solution might have been different than mine. One of my goals here is to showcase to you different ways of solving problems. That includes using different methods and different functions, and different ways to tackle the same problem in Dart. This is for 2 reasons. The first is that I just want you to know all the features Dart has available. But the second is, depending on your situation, you might not always want to use the same functions. You might need something differently. And the more of these you understand, the better you're going to do. How did you solve this problem? Please let us know. We want to see what you came up with. Maybe you solved it better than we did. Maybe you solved it in less lines than we did. Maybe you even benchmarked the different solutions and you found one that finished 100 milliseconds faster. My ears are open, my eyes are open, and my heart is open to hear what you have to say. This has been so awesome. It's been so fun. I'm learning a lot. I hope you're learning a lot. Stay tuned for our next video. Mwah!